Welcome to this CloudCIX tutorial on firewalls. In this video, we will discuss how firewalls can be used to control and monitor incoming and outgoing traffic in your CloudCIX project. Before we begin, it's recommended that you first watch our computer address numbering video in this series for a better understanding of the concepts we'll be discussing. Every CloudCIX project comes with a built-in firewall that ensures the safety of your data by controlling public access to your project. This firewall allows you to selectively allow traffic that you want to connect to your project and block all other traffic. On the left-hand side of this diagram, we have the public internet, where your project's users reside. However, this is also where malicious actors who want to hack into your projects are located. This area outside the firewall is known as the untrust or public zone. On the right-hand side of the diagram, we have your CloudCIX project, which you want to access but also keep safe. Inside the firewall is referred to as the trust or private zone. In the middle, the firewall acts as a barrier between the untrust and trust zones, allowing access to the good guys while blocking the bad guys. The trust zone uses private IP addresses that need to be translated to public IPs. This is handled by the firewall's Network Address Translation, or NAT feature. Only virtual machines that need to be reachable from the untrust zone require NAT. Now, let's log into CloudCIX and see how this works in action. For the purpose of this demonstration, we've created a CloudCIX project called Firewall Demo. This project includes two virtual machines, one Linux and one Windows, both of which are connected to a private IPv4 subnet of 10.0.0.0/24. The trust zone IP address of the firewall is set to 10.0.0.1. This address is commonly referred to as the gateway IP address because it serves as the entry and exit point for traffic to and from the trust zone. The Linux server is assigned an IP address of 10.0.0.2, while the Windows server is assigned an IP address of 10.0.0.3. To allow access to a virtual machine from the untrust zone, it must be network address translated to a public IP address. In this demonstration, both the Linux and Windows VMs are NATed to public IP addresses. This means that there is a one-to-one mapping between the private IP addresses in the VMs in the trust zone and their corresponding public IP addresses in the untrust zone. This ensures that incoming traffic from the public internet is directed to the appropriate VM in the trust zone while keeping the private IP address hidden and secure. Let's take a closer look at the private and public IP addresses of the Linux and Windows virtual machines. The private IP address of the Linux VM is 10.0.0.2, while its public IP address is 185.175.169.132. Similarly, the private IP address of the Windows VM is 10.0.0.3 and its public IP address is 185.175.169.81. To allow access to your CloudCIX project from your laptop, you will need to create allow rules that include the public IP address of your laptop as the source address. To find the public IP address of your laptop, we can use the RoboSock Who Am I menu item. From here, I can see that the public IP address of our laptop is 91.103.3.33. This address will be used as the source address in the allow rules that we create. But before creating the allow rules, it's important to understand that the firewall is a critical security feature that controls access to your project. By default, incoming traffic is blocked and only traffic that matches specific rules is allowed. This helps protect your project from unauthorized access and attacks. It's crucial to review and understand the default firewall rules that are in place, as well as any new rules that you create to ensure that your project is properly secured. When creating the allow rules, it's important to follow the principle of least privilege. This means granting only the minimum necessary access to achieve the desired outcome. In this case, we want to allow access to specific VMs from a specific source address using specific protocols and ports. By being specific about the allowed traffic, we reduce the risk of unauthorized access or attacks. So let's go ahead and create two allow rules for the required traffic. I'll click Manage and select the Firewall Demo project. Navigating to the Firewall tab, we can see four existing default firewall rules, which can't be deleted and exist to provide a basic level of security for new projects. We'll discuss these in detail later on, but for now, just simply note they're there. To create an allow rule for the Linux VM, we add our laptop's public IP address as the source address, and the private IP address of the Linux VM as the destination address. We select TCP as the protocol type and 22 as the port. Since we want to use SSH to connect to the Linux VM, we add a text name to describe the rule for reference. Allow access to Linux VM from my home office. Similarly, we create an allow rule for the Windows VM using our laptop's public IP address as the source address and the private IP address of the Windows VM as the destination address. We select TCP as the protocol type and 3389 as the port, since we want to use RDP to connect to the Windows VM. I'll name this Allow Access to Windows VM from my home office for reference. If you want to allow the entire untrust zone to reach your project, you can use the star character as the source address. However, this should be used with caution as it allows any public untrust IPs to connect to your VM, which increases the risk of unauthorized access or attacks. However, you may decide to use this in the case of a public website, for example. It's worth noting that you can use comma separated lists and hyphenated ranges for port numbers. So if we wanted to allow ports 22, 33, and 44, along with a range from 60 to 70, we could do so like this. But for now, we'll stick to a single port number for simplicity and security. The order of the rules can also be changed simply by clicking and dragging. After creating the new rules, we rebuild the project so that the rules are applied. The screen is showing a message indicating that there is no option for this current state at present. After waiting a minute or two for the rules to be applied, we can refresh the screen, verify that the new rules are in place, and now it's time to connect to my VMs. As I'm using a Windows laptop, I'll utilize PuTTY to establish a connection with the Linux VM via its public IP, which is 185.175.169.132. Since this is the first time accessing the Linux VM, I will accept the key. To log in, I'll use the username administrator and the password that was emailed to me upon VM creation. Excellent. Now I have SSH access to the Linux VM. Okay, now with the Windows VM, we'll open an RDP connection using its public IP address, 185.175.169.81. I'll log in with the administrator username and the password that was emailed to me when the VM was created. Since this is our first time logging in, we'll accept the warning. And excellent, we now have RDP access to the Windows VM. Before we wrap up, let's take a closer look at the 6 firewall rules in this project, including the 2 access rules we created and the 4 default rules. To do this, we'll go back to the Manage menu and select the Firewall Demo project and click on the Firewall tab. The first 2 rules block approximately 16 million known hostile IP addresses, which are identified by our RoboSock security application. The first rule blocks inbound traffic from these IP addresses, while the second rule blocks outbound traffic. By blocking outbound traffic, we can reduce the risk of a compromised VM communicating with malicious actors. The second to last rule allows all outbound traffic from the private network. This rule is necessary to enable the VM to receive updates and access the public internet. However, you could add a rule before this one to block this traffic completely or limit it to specific ranges. Finally, the last rule denies all inbound traffic. This is the default rule for inbound traffic. Keep in mind that rules are evaluated from top to bottom and that the first rule that matches the source destination, protocol, and port of the data packet being processed will determine the action taken. This is why the order of the rules is critical. I hope this information helps you better secure your projects on CloudCIX. See you next time.